So now that we know the interior of the function, and I think it's also important that we know the have different ways of writing function, and I'll show you some. Um, I'll show you some of the formal types that are commonly used. The first type is that got a function name. Oh, actually, in RStudio, for a shortcut, you put fun here, and see that there's a subnet. Press enter, and you'll get it. And there's my function name. And press tab. So that's input 1, input 2, input 3, and there do something with it. So I want let's just sum it. And the important thing is that the functions can take functions. Functions can take other functions, and sometimes it could also take itself with a limited number of iterations. That's something to do with the R option, but usually that's fine. So you could write another function here. Sorry. Say I got this one, and I could actually call that function within that. Or you could even write some recursive functions to replace the for loops. And a function usually have a returned value. That's something you write in C, like return something. But in R, you don't always have to do that. I mean, if you leave this here, it automatically means return or print in function. Second way of doing it is the short one. It's function I mean, if it's numerical, like if you want to solve a quadratic equation, and that's got to be square root of and if that's simple enough, and you could even do something like, right, so let's load those functions and see if it works. So the normal one is working. So I take the sum 6 and square it. So that's taking its so it's taking another function, and let's see this if that one is working as well. Sorry. So I got oh wait, I forgot. That's a very silly mistake. Yeah, so there's that basically solves the function. Now here are if I look at the body of those functions, or I could just type the function name, or uh, certainly, or if in case I forgot the functions of the functions, I could write a documentation or a package help. But the easy, I mean the easy way of one of the easy way of sorting out those functions are just you just type the function name without a bracket, and it tells you the lots of things about function, or you could just look at the body of the function which we already mentioned, right? But here's one kind of function which doesn't quite, which in this way you couldn't really know a lot of things about that. It's if it's written in this way. So plot is a function of those things, and it's using the method of plot, and it basically tells you nothing. And if you go to the help page, it says generic XY plotting, and what's important is that this is a very good example of object-oriented function. So, like I said, if I put a data frame, so iris is a data frame, it's gonna return this kind of plot. So something important to know here is that the type of iris is data frame, but if I plot, like, some variables and then the sign, maybe this could also work, right? But usually a function doesn't work like that, and it's basically it's usually because there's no general array that supports all formats of data, and there will be some errors. And if it plot like its second row and columns, this is also a 2D plot. So, and if I go, and there's more kinds of data. Let's just use certain typical time series, maybe time series. What do I have? Right, let's see. Monthly. Let's just use the air passengers. So air passengers. It's a time series, and if I do maybe I print this so that you can see what's going on within the data input. If I plot this data, air passengers, right, and it automatically recognizes that it is a time series data. And isn't that strange? I mean, this doesn't happen to a lot of functions. Now, one way of letting your function to do that is to use the object-oriented functions. So let's say you probably came across something like an objective CPP or something, and so basically the first thing is that you define class, and for a certain class of object, you have one certain functions that does something to it. So if I write, let's just say I want a function. I want to some kind of functions that does this. So if I plot I say if I use contour or something, that's not a good example. Let's just say the Fibonacci sequence, the good old Fibonacci sequence. If I write this function and I specify the name of input pit, and I instead of writing a function directly here, I go use method fib. Now this basically does nothing, but if I go numeric, so if a number if two sets of numbers are entered in this function, it basically tells you a plus b. So if a is 1, b is 1, then the result should be 3. And fib, if a list is put into the function, if a list is put into this function, and then the result should be the A object of the list plus the B object of the list. Let's just use this very simple and silly example here. Now, find this function. Now, basically, if you type here, just like I said, you see nothing. You see nothing of the interior, unless you type fib.numeric or fib.list. But if I put two values to it, like it gives you 2. And if I give a list of data, and it's telling you that say A is 1, B is 2, then adds A and B. Alright, so that's probably not a very good example. One good I can think of one example that I wrote is in my library called this MFVN, and actually let's just detach this thing first, and if I want some you probably know about the dataset of volcano, which is a volcano in Auckland. I forgot its name, but right. So let's just unload the package. Say if I get a function of two variables, x and y. Right. and I want to see x squared plus y. And if I plot f, it's not gonna happen. And if I want a contour, so if you imagine volcano, wait, what did I type here? Contour. So a contour plot is showing its the line with the same height with respect to two variables. Say one is latitude, or one is just length and width, or and it basically shows you height. And if you put a matrix or data frame to it, you get some height on the corresponding spaces. But this isn't quite very helpful when we are dealing with some math problems. I say if I want to demonstrate how a circle is drawn. So circle, not actually circle. Circle height, the height on the circle. Let's use x and y, and the radius of the circle is represented. It's represented by the height of the height on the graph, which is also the distance from one point to the origin. So basically you need this. And if I go to contour circle R, that's not working. It's not working because the class of circle R, wait, shouldn't type the parentheses here, it's a function. So if I want to directly visualize this function in terms of the two variables, its height over two variables, I need some functions that could extend this contour, which is already a f3 function, and letting it takes the function value and directly give me a visualization of this 3D data. So this is what this this library can do. And then I just kept making spelling errors. Right, takein function, and it does this. You know this. So I guess we need to make the aspect ratio to 1. Sorry. Alright, I haven't really updated this yet. Let's see. This function takes a function and visualizes it. But what if I got an expression instead of a function? Like, let's say now I instead of a circle I want a hyperbola, and I'm too lazy writing a function here. I'm just putting expression here. Right, and that's actually what it's doing. And so it's suppose suppose that if the data that's put if the data that is put into the function is expression class, it will translate it into the contour in this form. In certain procedures, And this procedure is going to be different when you directly put a data frame into it, or you put a functions into it, and more and more ambitiously, you could even, for the convenience, you could even do this. You directly put a string variable here, and let's just do, let's say what we got here, a string function, and let's just put in some strange things. Maybe cos y and times square root of x. And such thing is making your working more convenient in some ways, or it's not. It's all depend on you whether you want to use the function in program or not. Right, that's the second part of the video.